backwards from what we already had. So we're going to prove or show or explain why a quad is a parallelogram. Okay? At the top of your notes, you have the 5 ways to do this. The first way, if you can prove that both pairs of opposite sides are parallel, well, then it's a parallelogram. Okay, so if you can find same side interior angles that add up to 180, which make the lines parallel, then you have a parallelogram. If you can prove that both pairs of opposite sides are congruent, then it's a parallelogram. Okay? If you can prove that both pairs of opposite angles are congruent, then it's a parallelogram. So that'd be like if I give you a picture and I put 100 in here and 72 here, and then maybe I put 72 here. Using the knowledge from like way back in chapter 3, all 4 of these angles have to add up to what? 360. That would make this angle what? Did you really just do that in your head?
Yeah. Is it right?
144, 244. What's 360 minus 244?
Not right.
116.
Oh, no, it's too old.
So would that be a parallelogram then? Why?
I didn't because.
Why not then? Why say no?
I just said yes because it is right. It is.
This is a parallelogram?
Yeah.
If this angle's 100, this one's 72. This...
Parallelogram.
No, it's not. Because you need both pairs of opposite sides parallel, Ben, not just one, or both pairs of angles. Okay, so this wouldn't be because my 100 and 116 are obviously not congruent. Another way you can prove something is a parallelogram is that if the diagonals are bisecting each other. Notice these are all the properties of parallelograms in reverse. It's your quad tree and their converses. If the diagonals bisect each other, then it's a parallelogram. If both pairs of opposite angles are congruent, then it's a parallelogram.
So on that proof, we could have just said that if figure is a parallelogram, then diagonal bisects the angle. And then...
They don't bisect the angle. The diagonals cut each other in half. They don't cut the corners in half. Good question. Okay, and then the last way says if one pair of opposite sides are both congruent and parallel, then it's a parallelogram. Okay, this is the new one. This is one that's not a property. So if you have a quad where we'll say the top is congruent to the bottom and they're parallel, this makes a parallelogram, and I'll show you. If I put a diagonal in, this diagonal is going to be congruent to itself. Do you agree? Okay, and since the top is parallel to the bottom, wouldn't that make these angles congruent? Because they're alternate interior. What can you tell me about these two triangles? They're congruent by side angle side. What's it mean when triangles are congruent?
All corresponding parts.
Good, all corresponding parts are congruent. Therefore, the right side of the quad would be congruent to what? The left side. And if you have a quad where opposite sides are both congruent, what kind of quad is it? Parallelogram. Okay? So you don't have to do everything that I did in blue. If your picture just shows what's in black, one pair of congruent sides, and they're also parallel, then you can say it's a parallelogram based off of what we did in blue. Yeah, if you had it like this, you mean? Yep, that'd be a parallelogram too. I can prove it the same way. So if your picture has just this, that would give it a parallelogram. That's your 5th reason. Cool. I'm going to skip number 1. I want to go to number 2 first. It says determine whether the quad must be a parallelogram or not, and then explain. So this first one, the left side is congruent to the right side, and then the top side is congruent to this diagonal. Would that be enough to prove that it's a parallelogram? Why not? Well, what? Do you have to have parallel sides to prove that's a parallelogram? I mean, it would make the most sense. Colleen? Okay, good. That was the one I was looking for here. You need both pairs of opposite sides congruent to be a parallelogram. So since I have one set congruent, I need the other set congruent. I mean, I agree there aren't any parallel lines either, but.
It's really subtle, like really cool. Cool. Why?
B, is it a parallelogram?
Yeah.
Why?
I don't know.
Because it's got one side.
Yeah, it's that fifth reason we just talked about, because the same pair of sides are both parallel and congruent. If one pair of sides are both parallel and congruent, then it's a parallelogram. You don't have to show me by putting in a diagonal and prove the triangle's congruent. We already went through that proof. Then no. Well, I don't know. Let's see. So like if these are congruent but these are parallel, would make this angle congruent to this angle and this side. No, that wouldn't work, because that would be angle side side, and I can't prove triangles congruent by angle side side, so that would be a no. Good question. All right, let's go back to 1. For number 1, it says find the values of x and y that would make this a parallelogram. So x and y, what are they representing on number 1? We're back at number 1. What do they represent, x and y? Sides? Segments? The diagonals? Good, they're the parts of the diagonals. If we want it to be a parallelogram, what do we want the diagonals to do? Bisect each other, which would mean that AG is supposed to be congruent to what? And BG is supposed to be congruent to? All right, so find the value of x and y that's going to turn this into a parallelogram. Clayton, what'd you get for x? X? Piece of paper? Good. Should get 18 for x. Cheyenne, what'd you get for y? Good. Remember, when they seem funny, how can you check if you're right? Yeah, like sometimes you might get something where x equals 0. Just plug it in and check it. That's not wrong.
X equals 13. It still works. You sure it works? What about let me check. Oh, let me look at
Okay. I'm going to go to number 3 while you check. Number 3 at the bottom. We have to decide if there's enough information to prove that it's a parallelogram. You don't need to prove it. You just have to look at what's given to you and decide. So it's like number 2. No, you don't have to write a proof on this. It's just 2 of them. Okay. So, Dawson, if AB is congruent to CD, is that enough to say that it's a parallelogram? No. Why not? Good. Number 3A should be no. You would need both pair of sides congruent, or you would also need AB parallel to DC. 3B. I didn't write anything down. 3B. If E and G are both 75 and F is 105, does this give us enough to prove that it's parallelogram, Maddie? Yeah? How so? How do you know H has to equal 105? Are they? Did you hear Micah? Oh, you did? Oh, well, why didn't you say that? Okay. Good. You have to find the measure of angle H first, just to double check. And when you subtract 75, 105, and 75 from 360, this comes out to be 105. So then, since both pair of opposite angles are congruent, you have a parallelogram. Now, you don't want to assume they're congruent until you double check with your quad sum theorem. You need two pairs of opposite sides congruent.